Hello, ladies and gentlemen. This is Dr. Robinson, and we are continuing our studies. This time we're talking about probability. Probability measures the chances of an event happening based on the number of possible outcomes. Please note, possibility can be expressed as a fraction, a decimal, or even a percentage. Probability ranges from the improbable, zero, impossible, to all the way to certainty. Basically, if an event is to occur 25% of the time, one-fourth, it is unlikely. You've heard of the saying 50-50. That's half of the time equally likely, or likely, the 75% chance. And if it's definitely going to occur, that's 100% probability, certain. So those are the numbers and fractions and percentages that you should remember when you're dealing with probability. Impossible, zero chance of probability, 25%. Unlikely, equally likely, 50-50, one half. Likely, 75% chance. And certainly, or certainty, 100% probability. Here's our first question. There are three choices of jelly beans: grape, cherry, and orange. If the probability of getting a grape is 3/10 and the probability of getting a cherry is 1/5, what is the probability of getting orange? Okay, well, we have our different colored jelly beans here, and the grape is 3/10. So let's get that down there. 3/10 for grape. And we got 1/5 for cherry. So we need orange, which is going to be something, and that's all going to add up to one whole, because we have three flavors and they all have to add up to a total of 10/10, or one whole, because that's the total of the probability. If we have 3/10 plus 1/5, then let's change that 1/5 to 2/10. I multiplied the bottom and top by 2, and I add to that 3/10. That'll give me 5/10. And now all I have to do is take 1 minus 5/10, and 1 I know is 10/10, and that's going to give me 5/10. So my answer is going to be, the chances of getting the orange is 5/10. Remember, you take your grape and cherry, add them up, that adds up to 5/10. Subtract 10/10, which is 1, because they all have to add up to a total of 1, minus the 5/10 gives you 5/10 remainder, or 1/2 of the jelly beans are orange. So that was a good question. Here's another question you can try for yourself. A container has 2 gray, 1 white, and 4 black marbles. Without looking, if Erica chooses a marble from the container, which marble section is likely? All right, so let's see. There are 7 marbles there. I have 2 gray, 1 white, and 4 black, so that's a total of 7. So I got 7 marbles, and the one that is unlikely, that means not going to be having a high chance of being chosen. So out of the 7 marbles, the one that's most likely not going to be chosen, that would be hard, would be the white, because there's only 1 out of the 7. So I would think it's the white one that would be the hardest or the most unlikely to be chosen out of all of them. So let's grab this white one, B, and see if that'll be it. Yes, we're all right. So that's unlikely. Doesn't have a high probability. If you remember our chart, let's go back to our chart. Unlikely was like a 25% chance of being chosen. It's not highly probable, but it has a possibility, but very low. So make sure you take a look at that chart. So check your understanding, see if you understand it so far. If you have any questions, write them down. Be glad to answer them in the morning. So bring them in, watch the video if you need to, watch it again. Here's a question for you. Again, the container has 2 gray marbles, 1 white, 4 black. Without looking, this time Erica is going to choose a marble from the container. Which marble selection is likely? So this time likely. So take a look at your chart, see which one is most likely. And here's a similar question, the same amount of marbles there, and now we want to know which marble selection is certain. Certain. That's a good vocabulary word. So check your understanding, see if you get those right. I'll be glad to go over them in class, so I'll tell you the answer then. Here's a good question. Peter will roll a number cube labeled 1 through 6. A total of 90 times he's rolling this. What is a good prediction of the number of times the number cube will land on a 5? All right, so he's landing on a 5. So there's our number cube, and he's going to roll it. It's already on 5, so he's rolling it. The probability of getting a 5, would be 1 5, because there's only 1 5 out of 6 numbers on the number cube. So he's going to do that a total of 60 times. If I multiply that, I would get 90 out of 6, because that would be the number of times he rolled it, 90 times, and one occurrence out of 6 times would be the chances of getting 5. So if I reduce 90 out of 6, I would get 15. So I'd expect to get 15 5s. So the chances of him landing on a 5 would be 15. And check your answer. Again, you multiplied by the number of times you did it, and that would come out to 15, because the probability of getting that one little 5 out of 6 possible numbers is 1/6, and doing it 90 times gives us 15. In order to really see what he got, if he really got 15, we'd have to experiment and actually roll the dice cube 90 times to see if he would actually get 15 5s. He may not. When we do that, that's called experimental probability. Experimental probability is the ratio of the total number of times a favorable outcome has to the total of trials, or the times the experiment is performed. As the number of trials increases, the experimental probability gets closer to the theoretical probability. In other words, when we go back to Peter actually rolling his his cube here, if he rolls it 1 time, in theory, he should get 1 5 out of 6 rolls. So if I rolled it, there's 1, no, not yet, not yet, not yet. I got 2 3s, I notice. Oh, no. And that's oh, there's 1. And 1 more time. Okay, and I actually did get 1 5 out of 6. Now, if I did that 90 times, maybe I would get 15, maybe I wouldn't. But the more times you roll it, you get closer to actually getting 1 out of 6. So I believe I rolled it 6 or 7 times there. So sometimes you get lucky, sometimes you don't. That's why they call it probability. So here's a question that you can try on your own. Dan rolled the number cube 20 times. The cube landed on the number 3 6 times. What is the experimental probability that Dan will roll the number 3 the next time he rolls the number cube? So I hope you got something out of this video, and remember, watch it again. If you have questions, I'll be glad to answer them, and hopefully we'll see you next time as we continue our series in probability. Bye-bye.